Hello and welcome to GIZ's campus in Bonn, which consists of the newly built campus and the Meerander building. We are particularly proud of our climate-friendly cooling and heating generation, which uses refrigerants such as propane and CO2. I look forward to showing you these facilities. Come along. Here we are in the heating and cooling center of the campus. The specialty is that we work with 2 heat pumps with a total power of 1.5 megawatts. They use CO2 as a refrigerant. CO2 has a GWP, or global warming potential, of only 1. We use groundwater as our primary source since we have the great advantage of being located in the Rhenish lowlands, where we can access groundwater quite easily. Thus, we have a very efficient way, or the most efficient way, of operating these plants. Here we are in the so-called well system, where we have a suction well from where we extract the groundwater that we use to operate our heat pumps as a primary heat source. About 500,000 to 600,000 cubic meters of groundwater are extracted each year. They are cooled down in the case of heating and heated in the case of cooling. These are fed back into the so-called injection well via a filter in a plate heat exchanger. Here are our 2 heat pumps with a total power of 1.5 megawatts. You could easily heat 200 single-family homes with them. We need them to supply our building with heat and cold. The heat pumps use CO2 as a refrigerant. For safety reasons, since CO2 is a high-pressure refrigerant, the system must also be serviced regularly, which of course happens twice a year. We feel absolutely safe with these systems. Here we see the control system of the entire heating and cooling system of this building, where all functions are monitored and controlled. The heating curves are saved here, that is, the correlations between the outside temperature and the flow temperature, so that the building is warmed accordingly or it is cooled in the summer. Here, for example, we have the graphic display of the CO2 monitoring. Since the heat pumps are using CO2, they are of course monitored closely for how much CO2 is present in the air. Measurements are taken at the machines themselves and for the entire indoor air. From a limit value of 2000 ppm, everything is switched off and extractors switch on. We are now at station 2 of our tour, one of the 2 ventilation centers that we use in the campus building. In this ventilation center, fresh air is drawn in. It passes through a filter, a heat exchanger, where heat recovery takes place, and it's brought into the offices and into the rooms. In total, we condition 40,000 cubic meters of air per hour in the building. The used air is extracted from the building, for example in the office areas, via a sealing box into the corridor, which is under negative pressure, and it's extracted from the offices via the sound insulation opening. Here we are on the 3rd stop of our tour, in my opinion the most beautiful one, on our outdoor terrace. On the roof behind me there are the so-called recoolers, which ensure continued operation of the heat pumps in a dry, hot summer, when we might have problems with the groundwater. At station 4 of our tour, we see a typical office area of the campus. In the background you can see the temperature controller on the wall. Each area may be controlled autonomously. It may be heated and cooled. Depending on the setting of the controller, the temperature is adjusted. Fresh air is also supplied through the perforated structure of the ceiling, which is then extracted as used air through openings in the ceiling box. There is always enough fresh air available. We have now moved to another building, and this is the Meerander building, which was completed and occupied in 2015. This is the energy center, where cooling and heating are provided centrally by heat pumps. The heat pumps, of course, also use groundwater as their primary source, just like the campus building, but these use propane as a refrigerant. Propane has a GWP of 3, so it is almost climate neutral, and so we are excellently positioned in terms of energy. Regarding safety, the systems contain a total of 66 kilograms of propane. At first there was a lot of concern. Is this something we can do? This might burn or explode, but the machines are intrinsically safe. They have special suction devices through a non-combustible channel to the outside, and 66 kilograms of propane correspond to 6 gas cylinders, so the danger is very low. The conclusion to be drawn after our tour is that both buildings, the campus built in 2020 and the Meerander building built in 2015, are buildings with excellent energy efficiency. We are now at the end of our tour, and I am glad that you have taken the time to join me and get to know the systems and the buildings. And I hope you are now as enthusiastic as I am. I wish you a great day.